呢，我们要进行的是第2场的 TWNIC Peering Forum， 主题是 Peering 的未来发展及挑战。We will now move on to our second TWNIC Peering Forum, which focuses on the future development and challenges of peering. 这个场次呢，我们要聚焦讨论的是 Peering 网路互联如何提升网路的效能、扩充性还有安全性，以及如何因应像是法规面复杂性的这样子的挑战。In this session, we will focus on how peering can enhance network performance, scalability, and security in the future, as well as how to address challenges such as regulatory complexities. 这个场次的主持人呢是台湾大哥大的柯正义处长。The moderator for the session is Mr. Bill Ke, Director of Taiwan Mobile. I will now give the floor to our moderator. 接下来呢，就把时间交给我们的主持人，台湾大哥大柯正义处长，掌声欢迎。
好，谢谢大家好，我是柯正义 Bill 柯在台湾大哥大大概28年。那今天很高兴在这个机会跟大家再次见面。其实我在10年前大概也是在负责这个 IP 相关的部分，可是10年前后，我先转到 IDC， 然后10年后我们因为电信行业就是这样，我们大概3年5年就会换一个位置，所以我是10年后我又回到 IP 这个领域来，所以大概就是从 Internet， 然后跑到 IDC， 然后又跑回来 Internet。那这个场合呢，所以我们非常怀念这样的场合哈，所以在20年前，我应该是不止20年前了，30年前在台湾大学做 Internet 的时代，那时候都觉得说这个东西应该很不错，然后后来在进来台湾大哥大之后，就开始做相关的东西。那我们今天谈的是 Peering， 因为其实是在台湾 Peering 是一直都是我们几家业者在做比较小的寡占，或者是说想做一些小互联，但是呢，在现在的趋势是在国际上一直都有很大的那个 peering 的需求，我们很多 content 也需要一些 peering 来相关的把这些 content 带回来台湾，所以我们今天有这个场合来介绍一下 peering 相关的部分。那我们今天第一个讲者，我们是找到我们那个台湾大哥大负责 IP 网络的那个简维志 Jackie 简经理来帮我们介绍一下台湾的那个 Peering 的发展，跟台湾大哥大有关 Peering 的一些趋势。那就请那个简经理，谢谢。
其实刚刚我们处长有稍微介绍我，其实我跟他很类似，我也是，其实我在那个 IP 界也很久了啦。我从台湾固网开始，其实就是有我的存在啊，所以第一个台湾固网建立的这个网络也是由我建起来的。那我也跟我的处长一样，我前10年是在负责行动网，我开始是负责固网，然后前10年负责行动网，然后今年1月他又转为固网这边来，所以这个环境其实跟顾组长很多都很熟悉，回到一个以前的家一样啊。其实我跟 Peering 其实非常有渊源啊。其实我今天刚刚看前面的，其实我应该号称富爸爸，因为我们台湾固网在刚开始是一个非常小的一个 IXP 啦，所以我们对 Peering 这感觉是非常非常深厚的。所以我今天可能不一定会照我的投影片去讲，但是我大概先分享一下我可能在这20年所感受到，在我们台湾大哥大或台湾固网针对 Peering 的一些看法，跟可能就呼应到我的简报的第1页啦。我记得刚开始在20年前，我们台湾固网刚成立起来，我把整个台湾固网的网路建起来。我今天第一个遇到的问题就是 Peering， 在当时的来讲，我们是一个小小的业者，所以我跟 HiNet 接email就要7000多块。我跟CNET 的老大哥接 email 就要3000多块，我跟中国大陆接 email 要90块美金，所以我老板就说这个怎么办？我们光连上去就要花那么多钱，所以我们就很致力于在这方面的游走，也感谢政府单位。我想今天大家看到的是政府的跟 TWNIC 这边的努力，所以目前来讲，大家看到 HiNet 的互联成本现在已经降到大概不到30块，那 CNET 的老大哥跟我们现在也是平起平坐，所以大家是 free peering。所以这个是我第一个在 peering 的第一个感受。 那第二个感受在什么时候？就刚刚各位业者讲到的 CDN 这个事情，慢慢网络这样起来之后，我第二个遇到的一个难题就是，我想那时候在2008年，如果这里年纪够大的，应该有听过开心农场啦，或什么一些游戏啊。那一开始我们在连的时候，可能跟各个老大哥连完之后，再来也是跟像 Facebook 啊或 Google 会去做借接。可在当时的年代，2008年那个年代来讲，其实我们对于 Google 跟 Facebook 这些 content delivery， 因为它是为了侵占我们IXP 的市场，所以那时候大家是有一些争执在啦，就是说大家都是有一些可能希望说他来这边 call 要有付费，然后免费可能就会比较不好诸如之类。但是直到我遇到一件事情，就是因为那时候我们跟凯擘合作，我今天也知道台哥大跟凯擘是联合在一起，所以我就遇到很多客诉。很多客诉是什么客诉？就是很多人在 complain 我说，开心农场我每次要种一个田都比别人慢。那为什么会发生这样？我那时候才惊觉到一件事情，就是说，虽然我跟 Facebook 有直连，但是呢，我跟 CDN 业者因为你刚刚其实前面有一个讲者也有讲到说，海缆其实有时候一有断线就半年就才会修好，所以虽然我有很多 peering 直连，但是呢，当海缆发生问题的时候，我发现说我没有 CDN 的时候，我的很多的 content 会变慢。所以我的第二个在2008年的时候，我就发现说 CDN 非常非常重要，所以我就跟我老板们开始鼓吹说，我们可能再来就要开始努力去建跟 CDN 的一个界接。那所以各位可能等一下我有一份资料会说明说，台哥大整个在跟 CDN 直连跟 peering 的一个状态。那我之前可能在里面有一些经验，可能跟各位分享。那各位可能说到这里为止，我在 peering 到底是已经安稳了吗？实际上可能还没有。其实我最近也不太安稳的，就是像刚刚前面业者有讲到说巴黎奥运啊，那前一阵子有那个什么12强的精简赛，这是我面临的第3个问题。可能目前跟 HiNet 之间的我的借接可能是降到30块，没错。但是呢，当这种大型的赛事播放的时候，我们这个穷小孩台湾孤网可能流量一冲就冲到400多 G， 各位可能不知道。那你去把400多 G 乘以30块，其实每个月可能要付了不少钱啊。所以这个部分我是觉得，可能在整个互联方面，大家还是有一些努力的空间。不过也要感谢说，在这段时间大家的帮忙，不管是政府或者是 TWNIC 或 HiNet 的这些老大哥帮我们啊。但是这大概是我在一开始分享，所以针对 CDN 或者这些 content， 我一直是有很大的压力在。那所以说我第一个就会去找一些资料，就各位可以看到说，各位可以看一下第一页的资料，就是说目前各位很多人都知道说，目前你的流量里面大部分都来自 streaming。您知道吗？现在其实我们在分析流量的时候，以我们我们公司来看，我们看到里面的所谓的影音流量的占比大概是在60%到70%上下。那全世界其实我有去捞那个不管是那个IXPs 的资料，或者是DCIS 的资料，他们的资料是告诉我说，全球的 IXP 在5年大概会有130% 的成长。那互联的部分，在 IXPs 的 Y24的年底的报告是大概会有30%每年34% 的那个成长，所以在 streaming 影音的这部分，应该预估在未来至少到2008年，应该会到70%、80%甚至80%以上，所以这个部分是我们大家可以共同在努力的地方。然后再来有关那个行网或者是固网相关，我们行网其实每次都有所谓的用户的流量，每个人平均的流量大概是多少？其实台湾是一个怎么讲呢？是一个吃到饱的环境啊，所以台湾在每个手机的平均流量上，其实在跟其他世界国外比起来，我们是比较高的。所以我们大概我现在只是说我们公司来讲，我知道大概在40-50上下。那目前来讲，整个台湾业界大概是30到60 G 左右的一个平均的一个挖人的量。那如果以全世界来看的话，我看那份报告来讲，是因为其他国家并非是以吃到饱为主，所以它的流量其实是比较整个，它里面大概都是把钱花在刀口上，所以大概都是以streaming为主，所以平均流量大概在20 GB 上下左右。那在平台的部分，各位可以看到大概就是 Netflix 啊、YouTube 啦，可能等一下后面还有一份 OTT 的报告，可能会跟各位有一点息息相关。其实，在语言上面也会影响 OTT 的市场的生态。 比如说在台湾或东南亚跟中文语系的一些东西比较，所以各位可以看到像 YouTube 或者是 TWNIC TV 或者是跟中文有关的一个部分的 OTT 就在我们的排名是比较前面的。但在整个国外里面，英语系的话，可能等一下有一份报告跟各位稍微简单的一个分享这样。那这个是一个我们站在全世界的角度来国外来看这件事情。目前以 CAIDA 来讲，其实我们台湾即使是老大哥 HiNet， 在整个AS Number 的 ranking 的排行并不是很前面，其实是400多。但是呢，我不是说这个不好，而是说各位可以看到后面，其实我们在很多在 TWNIC 或政府或大家的努力下，其实我们很多都做到前20名或前30名。比如说 IPv6， 我们是前11名。比如说那个大家每次讲到 RPKI 的诸如此类，其实我们在速度上或什么上，等一下可以分享给各位，其实我们做的都不错。虽然我们可能在整个世界的 ranking 排名，在 ASLAM 的 topology 的排名并不是很前面。那这是一个我上礼拜去捞的那个 speed test 的 Ookla 的资料，各位可以看到，在 mobile 的部分，整个台湾业界来讲，我们的排行是全世界第29名。那整个 download 的速度是118，那 upload 是18，latency 大概是18 millisecond。那以固网的右边这个固网的角度来讲，我们的 ranking 其实是17名，然后 download 的速度大概是222，然后上行的话是19，然后 latency 是4，所以各位虽然我们即使第一个老大哥并不是在 AS Number 排行中，可是我们的网速其实在全世界是在前30名以内。那我们再来看 OTT 的比较，这里有一份资料是跟各位分享一下，就是说在全世界来讲，整个 OTT 的排名，因为我为什么对 OTT 特别有兴趣，是因为刚刚也讲了，我有3个经验，我目前还是持续的在帮公司能够在 peering 上能节省一些费用，所以我们公司是每个礼拜我都会去捞相关的资料，然后跟我的老板报告说，我们可能去跟哪个业者直连，可能会对我们的连外频宽是有节省的效益。那我们来讲 OTT 在全世界的排名来看，第一个就是 Netflix， 第2个是阿玛荣，第3名是迪士尼。那第4名是 YouTube， 我是很讶异 YouTube 是跑到第4了。可是你在台湾的部分，你可以反过来看到，台湾的 Netflix 也是第1名，但是 YouTube 在台湾是第2名。那我在想 YouTube 因为它比较 open， 它也有中文语系，有很多什么都可以放在上面，所以在我们台湾来讲 ，YouTube 反而是排在比较前面的。那各位可以看到第4名的 LINE 是亚洲这比较特别的地方，整个全世界你可以看到 LINE 并没有排行在10名内，但是在东南亚的部分，LINE确实，LINE因为我想跟我们是很有习惯，跟日本整个的相关的一个合作。那后面就什么爱奇艺、巴哈姆特 LITV， 这个可以给各位分享一下。那这一页来讲，其实老生常谈啊，我只是想说，还是透过这个会议来跟各位讲，可能分享一下整个互联的部分。我想以前到现在都讲中立性嘛。那不要有独占的部分。那我想政府跟TWNIC跟相关老大哥都做得不错，只是说我是觉得刚刚讲一个那个直播的一个范例400多 G 的范例，还是有可以努力的空间啦。那公平跟平等互惠这个大家都知道，然后互信与自律来讲，就是因为我们之前我想 HiNet 他也有经验说，之前常发现说借接的 PNI 业者可能他在 BGP 的设定上没有一定的规范，就把大量的路由导进来，所以这个部分在互联的时候，就刚前辈也有讲到的一些互联所需要的基本条件跟约束的条件，这个东西都是政府跟 TWNIC 跟大家都一直在持续做，我想未来也会持续在这方面进行。那至于说技术的一个部分，各个 ISP 可能的走向就未必很相同，但是在 IP 路由的部分应该是相同啦。不过等一下我稍微简单说。以我的愿景来讲，我台哥大跟台固来讲，未来我会往哪方面去做走向这样。那市场规模来讲，这个其实一直是台湾的痛。为什么？因为其实我们台湾的 XP 业者不多，只有3个，新加坡有11个。那 XP 业者来讲，其实是一个能够让未来这个 content 越做越大的一个关键啦。不过这个部分也非我一人之力，我只是说在这个 XP 我们还有一些努力空间。那我也知道政府跟大家相关这个20年来的努力，但是我觉得我们还是要持续的往全世界去走。 那因为我知道全世界的XC都开始所谓的Cloud Edge 的概念，那我们其实台湾还在这方面，我觉得还是有努力的空间了。那在那个技术的演进，其实前面的先进都讲了几个技术 ，IPv6，我想大家都知道，现在其实台湾做的不错，而且是全世界前10名。其实最好的名次，我记得刚开始做起来我们是前8名啊，那可能现在其他业者也慢慢赶上了。那 RPKI 其实我们一直都是 TWNIC 这边跟NCC 这边在要求，所以我们这边的至少在国内的部分是90%。我昨天看资料是99.4了，但是至少是在98以上。那 RP 我想说是最近 IXP 大家在推的，也是 TWNIC 这边在推的。那再往下走的部分，我们可能大家就是有一些见解，未必很相同。在我这边可能会比较推，并不是马上做 SDN， 我比较倾向的是 segment route 这个部分，因为 segment 可能跟 SDN 很类似，但是它的好处是没有 SDN 那么复杂，然后它在做某些部分来讲，可能相对是单纯，比较容易入门啦。那再来最后一个是 AI 的部分，其实我们公司其实做了蛮多，各位可能不知道说，在 ISP 的业界里面，通常在比较的时候是这周跟上周比较，或者是有些流量来讲是跟之前的什么做比较，所以它是一直变动的。所以我们公司其实之前在做这方面有做一个所谓的RIMA 这种演算法去做，可以根据不同的时间，它的 threshold 后有不同的 baseline。那现在在我们那个林总的一个支持下，我们要求每个长官，像我这个一定都要有所谓的，我们是什么 AI 的工具啦，都要求我们每个理智辈都一定要有这个 AI 的技能，而且它要作为考核的项目。所以我们公司在 AI 的推动来讲是蛮积极，而且是有 KPI 要达成的。那这张图我稍微花一点小时间稍微解释一下说，各位可以看到，右边这边来讲，大概我们分 Pay Peering、Free Peering。那左边来讲有所谓的 Cache， 各位可以看到我有分 TF 跟 TWN。那这也就是2008年到现在我一直在努力演进的部分。各位都其实刚前面业者也知道说，我们积极在建 Cache， 可是 Cache 的部分它一定要所谓的把这个 Cache 的流量把它可能要有一个线路把它连进来，所以通常我们会是 Free Peering 的部分来做这个借接。那以我2008年到现在经验来讲，我们建一个 Google Cache 在我们的身上的时候，其实大概100G 会有20%到30%会透过 Free Peering 把这个100G 的流量给让它可以充分去使用。等于说，在 Google 跟 Facebook 大概经验是这样，可是 Apple 就很特别。Apple 我建了 Cache 之后，它的直连其实很特别，它直连某种角度它的巅峰时间是在凌晨的，不是在我们常听到的 rush hour 的部分。那它的比例也很特别，可能不是20% 跟30%。等于说，在这个建立这个里面，你可以学到很多这方面的一个经验值啦。那所以我们在布建的时候，我们当然都说能尽量能跟 CDN 业者借接的，我们会尽量放 Cache 在我们身上。那我们的 Cache 里面也有分台哥大跟台固，所以在我的固网跟行网，我也都有做 Cache 这个件事。当行网到一定程度的时候，我就会把固网的某些 Cache 往行网这边请他可能建这样，比如说我们最开始的 Facebook 跟 YouTube， 后来我们慢慢可能建 Apple 的这个 Cache 这样。等于说 Cache 部分在我台哥大这边的布局大概是以这个为主，然后中间当然有所谓的 RPKI 的借接，也所谓的钱的部分，就是说你往右边这边来讲是越花钱，往左边来讲它比较省钱，然后速度也比较快，但是相对我要投资的局内成本就比较多这样。但是它的好处就是可以让用户的感受度增加。那在我连外频关的部分也可以做一定的节省这样。那在我们中间的核心技术当然有 IPv6 跟 V4， 那也有 DDoS， 也有刚刚 RPG， 还有一个所谓的 Anycast 的，我想这个业界同伴应该都知道这个技术。然后刚刚有讲到我们现在在朝 segment route 跟 AI 的工具去加强我们整个骨干的 redundant HA 的相关机制。大概这张图大概简单跟有这个资料我都有分享出去，到时候有兴趣的同仁都可以欢迎。然后这个部分大概简单说一下法规，因为现在往外布局的时候，你也知道，不管是 banking 业者、银行业者，或者是很多 那个 secure 的东西都越来越重视，所以在法规部分，我们台湾这边其实我是觉得，可以慢慢可能要加强这方面，在跨境这个领域的一个法规的一个制定。那像欧洲或非洲都有制定蛮不错的一个学习的方式啦，我是可以在这里跟大家share一下。其实这里我也不是很专家，只是我看到的。很多他们的这个外面的那个 report 是这样的一个说明，所以这个部分只是提供给各位参考。那这个部分刚刚大概讲了差不多，我就不再细讲。那最后可能跟大家分享一个小的，就是 IXPs 的资料，就是说目前来讲有一个往 Cloud Edge 的一个角度，就是说 Enterprise 就是我们目前企业的数位化，可能企业会做所谓的。IP， 比如说它有机器工厂，有所谓的 cloud 化。那 service provider 就像我们台湾固网、中华电信这样，在这个里面的一个成长部分，在 IXPs 的报告里面，我觉得可以作为参考。就是说，其实，在台湾，我只是想跟各位讲说，在亚洲的企业的数位化，其实比其他业者来得快很多。其实我后面的资料是有点笔误啦，我们大概是42%，那全世界平均是39%。在企业的数位化部分，那整个 service provider 频宽的互联来讲，我们大概是这个全世界是62，然后我们大概是61，所以在 enterprise 的数位化的成长，台湾其实是跑得蛮前面的。我只想这个32写错了，是42，所以我跟各位有来上课有来听的就知道我要修这个东西。那大概整个报告我先讲到这里，最后做一个结论啊，就是整个语音串流的就是语音串流与数位应用的全球发展对于互联的稳定性的挑战，其实刚刚有稍微提到。那台湾的基础经验其实不错，我刚刚讲我们在整个不管网速或 redundancy 或规模上，但是中立性与国际的部分，我是觉得还可以再加强一些，然后推动大型的这种交换中心，完善法规跟技术部分，然后就像今天这个会议或很多这种交流的会议，来提供大家互相交流，整个台湾当做一个大世界来跨出这个世界，我们有更多的吸引很多吸电业者来台湾做投资这样。那刚刚最后一个就是我们的其实整个的复合成长是34%，然后我们的企业的数位化其实是40%，其实在全世界里是属于佼佼者。那最后我大概先到这里做一个 summary， 然后如果各位有问题再发问，我的报告先到这里，谢谢。
先来那个 Q&A 的部分吧，看大家有没有什么问题。没有问题的话，我问一个问题好了。我们都知道说那个 IX 跟那个 Peering 的趋势，渐渐的，你刚刚也提到说那个 content 业者越来越多，所以 Edge Cloud 跟 IX 有没有一些整合或合作的可能，或者是什么样的方式来让 IX 跟 Edge 能够更加强的合作，让整个台湾的 content 的速度跟 capacity 都可以增加？
这个问题有点大，但是以我目前能了解的，就是当然是还是积极的走出去，跟像这种会议多跟大家接触，然后讨论，然后像我们公司就一直积极在跟各位 IX 可能前辈学习，然后也欢迎各位指教，然后把这个大家的互联能够更紧密，搞不好我也可以跟很多 IX 借鉴，然后很多人也可以跟我这边做连接，然后大家互相讨论，像多一点像这样的会议，或者上礼拜有 NGO 的会议，可能这是促进整个台湾在 IX 跟借鉴的一个，我是觉得一个比较好的方式啊，大概是这样。
好，谢谢那个 Jackie。那我们下一个 ，OK， 我用这个麦克风啊，你麦克风给我。麦克风。对，我们下一个那个讲者是来自阿卡买的 Kens 是阿卡买的 Principal Network Architect。那他其实在这个领域上，事实上有10几20年的那个经验哦。那今天他来分享我们那个他在阿卡买跟那个 APNIC 这边有关 Peering 跟相关的那个技术上面的 update 跟那个建议。那欢迎 Kens。
好，谢谢大家。 还没有。因为我的中文讲得不太好，所以我还是用英文啊。PowerPoint。Oh, how? So I just have a very quick introduction. Let's see. Yes. Yeah. So I'm one of the network architects from Akamai. I'm from Hong Kong, but now I'm based in Singapore. So it's good to here to share my experience here. So today the topic that I'm going to talk about is the peering trend and the challenge. So this is the topic that I'm going to cover today. So I'm going to talk about like sorry, maybe I stand here is better. So I'm going to talk about like a very brief introduction of Akamai, just in case you don't know. One slide about the our current Akamai deployment in Taiwan. And then I'm going to talk about the trends that we are observing in general, what the peering trend that we are observing, and then finally bring in some points about the peering challenge. So Akamai, I think a lot of you guys know about Akamai as a CDN, because that's true because we start from CDN, but over the last 25 years, we have been expanding our service to security and also the cloud computing. So this is the platform that now we are called the Akamai Connected Cloud. So it consists of a lot of edge capacity for the CDN. There's over 1 petabit per second, and we have more than 4,200 locations and connected to 1,200 networks and deployed in more than 130 countries. And we do have a lot of staff to support this platform. So in Taiwan, this is our deployment. So I think a lot of the ISP already mentioned. Now our CDN is actually mostly deployed inside the major ISP. So we have a lot of cooperation with all the major IPO network, of course, including HiNet and Taiwan Mobile and etc. So our deployment is mainly to cover the deployment in all the 3 major cities, Taipei, Taichung, and Kaohsiung. And we have 2 infrastructure nodes. So the infrastructure node is where we do PNI and ICHA peering. So we are in Chief LY building and also in Zhonghua Banqiao. So at this moment, we are connected to 2 internet exchange in Taiwan. One is TPIX in Chief and also the TWIX in Zhonghua Banqiao data center. So then I'm going to talk about the trends that we are observing. This is not specific for Taiwan, but it's like globally what we are observing that happening about peering. So I think a lot of people mentioned that the internet traffic is keep growing, like 34%. So with the internet traffic growing, that's why your interface, the peering interface, your transit interface, your IX interface, all have to be increased. So one thing that to increase is increasing the port. I think in the old days that we are talking about like 1G, 10G, but nowadays from Akamai perspective, we are slowly fading out 10G port. So now with all the new peering requests, if you come to Akamai, we say minimum is 100 gig. And for the large peering partner, now we also have 400 gig E to connect to them. So of course, this is all case by case, but this is now the new standard for Akamai. And you also see that the trend is going for 400 gig. It's not that popular yet, but if you see the traffic growth of like over the next few years, you will see that when 400 gigs becoming more popular, like when your network device, when the costs all come into play. So but at this moment, you will see that a lot of large IX, transit providers, hyperscalers, they all support 400 gig already. And this is not only Akamai that fading out 10 gig port. So if you're looking at the peering policy of other hyperscalers, like Google, Microsoft, Amazon, this is what I exactly copy from the peering policy website. So you see like Google say, oh, they only support 100 gig LR4 and 400 gig LR4. And Microsoft say they must all be over 100 gig. That's over 100 gig mean like 100 or multiple 100 or 400. And AWS is the same. They say that they only support 100 gig or greater. So you see that for all these large providers, and actually I'll just give some example here. If you look at like Fastly, Cloudflare, and all these large providers like ByteDance, etc., they are all require at least 100 gig interface. So this is one of the trends that we are observing for the port speed. Of course, for smaller ISP, of course, they can still do 10 gig peering. But for all the large cloud providers, CDN, OTT, I think 100 gig is now the minimum. Actually, it is also applying to the cache server that we deploy. The other thing is about the optics. So I think I mentioned the 100 gig is the minimum. So but for 100 gig itself, in the traditionally, I think up to now, the most common popular optics that we use is LR4. But with the coming new technology, there's also a 100 gig LR, or sometimes we call LR1 just to be, but the technical is called LR, but because it's only one single wavelength, so now people just call it LR1. So the difference is the different modulation. I don't go into all these optical technologies, but basically the optics that for 100 gig, we are seeing more and more requirement, and from Akamai perspective, we are actually all also more prefer LR1. It's come into a few reasons. One is because LR1 is actually cheaper, and the other thing is if you have a 400 gig router port, when you do a breakout, instead of doing 2 LR4 breakout, you can do 4 LR1 breakout. So that means essentially you have a higher port density. And this is about the interface, the physical trend. And the next is about the route server. So I think a lot of guys, you do peering with the route server. But what we observe is some of the large telco or some of the large cloud providers, they are being not to peer with the route server, they are withdrawing and even stop peering with the route server. So for example, like for Akamai, we are, at this moment, we are still quite open, actively connect to the route server. But what we are seeing is because there are a lot of operational challenge, especially when it comes to any class prefix. Because when you advertise a prefix to the route server, you don't know how far it will be being propagated. And there's also a higher chance that you have a route leak if you just simply advertise your prefix to the route server. So of course, the route server do have their function. It's simple, just one single BGP section, then you can peering with all the members. But we'll see that there's a balance of peering with the route server that you have to consider about the security and the management. But we are seeing that more and more large providers that they are actually withdrawing from route server. So if you go to the Google peering website, they are starting to withdraw from route server. And even actually more, they actually go further. So if you go to their website now, they say that they are not accepting new public peering requests, because slowly they are also maybe withdrawing from some of the IX. And the other things that we are observing is automation. So because you think about that, there's all of the large players that they connect to 100 IX, and each IX have hundreds members. So day to day, they have to handle a lot of this kind of public peering requests. And it could be a lot of email back and forth, and then a typo, mistake. So we are seeing that a lot of providers, they're starting to do automation. So instead of you send an email to them or peering at abc.com, now they say that you have to go to their online form. And then the online form will actually also integrate with like PingDB. So they have an API to pull in the PingDB information to make sure that, to check where they can peer with you, or there's already a section. So there's an article about, I don't go into detail, but there's an article from Facebook and Gcore about how they do automation. Of course, this applies to like public peering. And then if you want to peer with, let's say, Tencent and Alibaba and Cloudflare, they will simply ask you to go to their website to make a request. So then if you go to there, then you fill in your AS number, then they populate all your PingDB information and do a matching, and they can even give you the traffic information. So this is to avoid a lot of human mistake, and then there's a lengthy process instead. So then after automate this, of course, some of them are doing semi-automation. What that means is you send a request, and actually at behind there's also still a manual process, but they just click approve or deny, and then you get an automatic email, and then they automatically configure that on the router. So this is shortening the provisioning period, and a lot of people are doing this for the automation. And then the other thing that we're observing is there's more and more IX, which is actually good, I think, in Asia. especially on those emerging market or developing countries. For example, like Vietnam, it used to be only one national IX, VNIX, but now we are seeing the PBX now go into the market because of the regulation change. We're also seeing a lot of IX are deploying in tier 2 cities. So for example, like in Thailand, you see IX in Chiang Mai. If you go to Malaysia, now we have IX in Penang, or Johor, or East Malaysia. And then if you go to Philippines, you see IX not only in Manila, in Cebu and Davao. So we are seeing that there are more and more localization of traffic, not only like within the country, but also within the tier 2 cities. But that's a good news because I think if more IX, then you have more choice. And especially for developing countries, I think there's still a lot of room to growth for their domestic connectivity. So these are just some example of the new IX that I think they are mostly like in the last 2 or 3 years. And there are, of course, some new coming up. And other than the new IX, we are also seeing IX, they are interconnecting each other. So there's a few reasons for that because number one is the market may be mature. So they want to connect to, they want to get customers from the other countries. For example, like in Taiwan, you have TPIX. They partner with JPIX and a few others. What that means is you have a Taiwan ISP, you connect to TPIX, and then you can do a VLAN, and then you do remote peering with JPIX or DKIX. So it saves you a lot of cost because you don't need to set up a POP in Japan. Then otherwise, you need to go to buy a router, co-location, and IPL, and you talk to the IX. So there are a lot of process and a lot of investment. So if you do a remote IX, it's very simple. You don't need to sign you just sign a single contract with, let's say, TPIX, then you can connect to JPIX. You don't need to think about the Japanese language. You don't need to think about you pay in Japanese yen, right? So all this simplifies the operation. And it's easy to scale because you also don't know how much bandwidth you have with Japan. So if you do a remote IX, then you can measure the traffic, and then if you think it's sufficient, then you can build your own POP, and then you have a direct connection with the IX. And these are some example of the partnership that, again, this is also over the last 2 or 3 years. So just one clarification. Hong Kong X and JPX. JPX is actually a reseller, not a interconnect, but JPX by itself, they're also an IX, so it's quite interesting. The other are more like a IX to IX partnership, so they are having a VLAN in between. And for example, like BBX, they have VLAN by itself. So you can have BBX Hong Kong and then connect to BBX Tokyo or BBX Singapore through a VLAN. So there's a lot of this kind of features that I would say when you connect to an IX. So I finished the peering trend that we are observing. And then I'm going to also mention the peering challenge that we are seeing. I think first of all, that is a lot of challenge for when you go to a country, then you have to talk about with the incumbents. So a lot of countries, I don't mention them, but they also have, of course, they have their major eyeball, the incumbent. So this is a challenge that is very difficult to deal with them. So you either don't peer with you, or you have to pay, or you have to peer with them only outside their country. So this is impacting the performance. And some of the ISP that they also try to monopolize their eyeballs. So what that means is, they used to be peer with you in the in-country, we are both happy, and then now they suddenly say that we have to pay. So there's some this kind of change when the ISP, their policy change. And with this change, that the policy change, that means there's a lot of traffic being routed out of the country. And for this kind of peering, that's also not only happening between like CDN and eyeball. The most famous one, I think you can read on the website, is the Meta and the Deutsche Telekom dispute. So they are disputing and up to the court. I don't know about what's now, but also a lot of peering dispute between the tier 1. So there's dispute between like Tata and Cogent, NTT and Cogent and Avilion. So when the tier 1, they have this kind of dispute, it's impacting the whole global ecosystem. So I think everyone will suffer when the people change their mind. I mean, the global tier 1, they suddenly don't peer with each other. So this kind of change in peering policy is also impacting the stability of the internet. Of course, when you change the policy, it's not only the performance, sometimes also have a cost impact. And the last point that I want to mention is when we go to a market, we always want to have more choice. I mean, we are a CDN, so we want to have more neutral data center, we want to have more IX. Of course, we are seeing that in Taiwan that you are not only have TPX and TWX, we also have like Fox and some others. But I would say that if a healthy market, you have like 2 or 3 carrier neutral data center, that would be great. So there's a success case in Bangkok. I think Telehouse is doing a great job when TCCT is more difficult to deal with. So I think the community, or they have a very passion about to build a new carrier neutral data center in Bangkok. And the other thing is because of the net of choice of the IX, so we are, I mean, as Akamai, we are also trying to help the new IX if possible. So when there's a new IX and when their traffic threshold or meet our requirement, we're also trying to connect to them. I think this is overall is improving the market competitiveness, not only for us, but also for the whole ecosystem. So that's all my presentation. So I just concluded talk about the Akamai connected platform. We are CDN, security, and cloud now. There are peering trend due to the increase of the internet traffic, so there's an increase in port speed, the change of using LR1, and then there's also the change in policy to a web server. More and more people are doing automation, and there are new IX and IX are connected to each other. And of course, this is and then the challenge is the peering with the incumbents as usual. And then I would say that we hope that there are more choice in terms of carrier neutral data center and more diverse of internet exchange. That's all my presentation. If you are interested to peer with us, so we have 3 different areas. So it's CDN, security, and also the cloud computing. So drop me an email. Yeah, if you are interested to peer with us. I think that's all my presentation. Thank you.
谢谢 Ken 请问现场各位有没有什么问题要问的 ？Any question for Ken?
好，没有就Leo.
Hi, Ken. And it's many thanks for your presentation. And we know the CDN is very important for all the user and the ISPs. And may I know, is there any AI application or IoT application have any impact with the CDN and for your services?
I can only talk about from Akamai perspective. As far as I know, I mean, I don't see any impact from like AI or IoT for our CDN services at this moment. Yeah. Well, I think the AI is not like, I mean, for CDN, your content have to be like cacheable. Yeah. So usually the AI is, everyone asking different questions, so it's quite difficult to cache the answer. And every time you ask the same question, it's the ChatGPT also gives you a different answer, actually. And for the IoT, I think they are also not that much traffic, I would say. And the content also probably not catchable as well, because IoT, you collect a lot of information and you send it to an aggregator. So it's also more push data than we are pushing data. Yeah. But we do see a lot of people are using CDN not only for the traditional content, but also for API. Yeah, that's what we are observing. You have to go to the mic now. Yes.
Hi, Kims. I'm from Time Mobile, and I'm Time Mobile IP Transit and also Peering Manager here. As I want to ask a question about that, because a lot of ISP as us, we have CDN and also peering, maybe with Akamai or maybe with a lot of contact contact company, maybe just like Google, Facebook. But which one do you think much more important? CDN is much more important, or peering is much more important? Which one would you prefer that ISP as what we can do in the future? Thank you.
Are you comparing between cache server and PNI?
Yes, because the traffic is going on those two ways.
Oh, okay. Yeah. I can. So I first bit on behalf of Akamai. I think we always prefer cache server, but our cache server also need to have a certain criteria to deploy cache. I would say most of the large content provider they would prefer a cache server, because cache server usually is deployed within the carrier data center. So, but if we are deploying let's say PNI, it's usually a connection between a public infrastructure. So you may have a backhaul to your let's say broadband gateway or your data center. So on that part, that could be a potential bottleneck, especially when it's doing an event burst traffic. Your connectivity between the data center and the connection data center and your own data center maybe maybe have a bottleneck. But if the cache server is within your, let's say, next to your broadband gateway, then you kind of removing that bottleneck as well. So that's why it's also a bit probably cheaper. I mean, you don't need to provide the backhaul to the data center. Yeah. So I think it's a win-win thinking about to deploy cache server within your own carrier data center compared to peering. Thank you.
Thanks, Kent. Our next speaker is comes from Japanese. His name is Taiji. Taiji, can you hear me? Okay. Taiji is a senior expert from TWNIC, and he has a lot of contribution for the RPKI, for the ROA, and today he will give us some peering development and also the security concept of the RPKI and other security development in the internet. Please help this lot. Welcome, Kenji.
Thank you. I'm very happy to have this presentation, but I'm not so happy without being there, because I attended the TWNIC event twice, and I felt the community has a very good mood and very good conversation, discussions there. My presentation title is Best Practices for BGP Security and RPKI Deployment. But I'm not sure this is the best, because I will show the number of the ROV for both Taiwan and Japan, and the Taiwan has the better numbers too. I hope this presentation has some information for you. This is the agenda. First of all, I will talk about the deployment status in Japan, RPKI deployment. And second one is the news, RPKI cache servers in major IX. The third one is about our project, KOLKA project. It is for checking effectiveness of ROV. And I will talk about the motivation for the project, and I will show the website. You can check your network is protected by ROV using RPKI. And the last part, I will mention about the deeper insights from the results. The topics. RPKI cache servers in major IX. In Japan, we have 3 major IX, and others are like educational networks or regional IX, but three are very major IX. And they started your RPKI CAS server, and one or two are public CAS server. So not only the customers, but also others can use RPKI CAS server for ROV validation using RPKI. They started until 2024, so they are already ready, and it's very impressive. The most clean model is doing RPKI CAS server in each AS, very near from the BGP routers, but many of the BGP operator don't want to create or operate the RPKI CAS server by themselves. So IX has thought they need to serve CAS servers for BGP operators. So we discussed many times which CAS server should be the best for deployment, wider deployment in Japan, and most of them answered their own CAS server, but not for all. And the answer is should be raised from the very active members. So those CAS servers should help the many operators, I think. This is a ROVista graph. We can see the coverage scores of ROV. ROV means origin validation using ROA, and the scores are very similar to Japan and Taiwan. I'm not sure the score is. It should not be the simple coverage, but this picture shows 28.9. So I said Taiwan has better scores, but I got the second image. I think this is the algorithm changes in recent weeks or months. But nowadays we as a Japan and Taiwan has the similar scores. In Japan, we have better but less than Taiwan. ROA coverage about 70% for the BGP route. The coverage means that the ROA covers the prefixes in the BGP routing table. So 70 is not bad scores percentage, but for ROV, we have not good coverage. According to the TWNIC labs, for Taiwan, 73.1%, so very good percentage, but in Japan, for Japan, 33.77. So ROA cover is not bad, but ROV is not good. Then COCA project. COCA means efficiency or effectiveness. In Japan. By showing the percentage to operators, not sound so much because Japanese people, maybe Japanese people's property, we are very slow, mild, but without confidence, we cannot make things forward. But if we can show if it's Japanese project, if we can show the effectiveness of ROV, and sometimes we can compare with the competitors for them, operators, competitors, then we can make people's motivation to the forwarding direction. So this project, the purpose is to check whether protected by ROV, I can say this website is protected by ROV or not. And second purpose is to analyze effective points. We are collecting the traceroute results and the ROV results, so we can guess which point is protecting where, or how wider ranges are protected by some specific ASs. So we need to analyze for showing such results. So we are building analysis infrastructure and AS network, and integrating with RIPE Atlas at this moment. This is how it works. The right angled square shows the target. We picked up the DNS servers, government website, or bank, media, EC site, and this is the internet and transit network, and JPNIC's testbed network for COCA project. This testbed network has 3 networks. It should be resulted as valid prefix. Prefix valid means that ROV result. Invalid prefix and not found prefixes. And the packet sent to the target from the 3 networks. And if from the invalid prefix cannot reach to the target can be seen as protected, because invalid prefixes routing information is filtered between the testbed to the target. So this test is only said the target is protected between us, between JPNIC's testbed network and target network. And we built the website called ROVCheck. So this QR code has this URL, so you can check this TWNIC Peering Forum's venue network is protected or not. We put the website like this. It's on the valid network, but we can test via the script from the web browser can access to the valid prefix, invalid prefix, and not found prefixes. And the result shows if the invalid prefixes cannot reach from the venue, from the target network, the network should be protected. All tests is done in a web browser, so you can test with your smartphone or web browsers. We collect and store every test result with IP address and timestamps, not the personal information. The test result it's like this. This is done in IETF 122 conference network, and this is very interesting. IPv6 network is showed as protected, but before it was not protected. But this is not just protected or not. It needs more deeper analytics because the network may be affected by peer routes, not just the transit routes. And the protected is said for some specific areas, but not for all internet. So this website can show very attractive pictures, but this is not the actual deeper results. But this can get the people's interest for the ROV. That's the actual purpose. This is the last slides. ROV check insight and improvements. We observe the flapping state, valid and invalid. So this is a Grafana showing. Not the all percentage is not 100%, shows that the result is not the simple gathering of the valid, invalid, and not found. Some routes shows valid sometimes, invalid sometimes, and sometimes simultaneously observed the different results. So we need to analyze analytics on this. Future works, trace route acquisition, it's too difficult over web. We need to trace route, we need to see the path. And integration with RIPE Atlas with COCO project can expand the observing point. It's not just between TWNIC and target. Thank you for listening to my presentation. And I checked February for 48 website, Taiwan government website. 31 was protected, but not for all. So if you're interested in this kind of check, please consult to me and check together and protect your website and your important service like DNS. Thank you for all. Thank you. That's it, my talk.
Thank you, Taiji. And I would like to ask Eddie, is there any question about Taiji? Taiji, I want to have a question with to you because I see that because NTT is the #1 ISP, so would you like to have a test with the ISP, for example, NTT? Because I think this project will have need a lot of capacity for the testing if we want to push the RPKI, ROV to the network. Do you have any plan to the ISP, for example, NTT, to do this trial?
Yes, good question, and it's difficult part of the test to NTT. NTT has a provider name as OCN. They do ROV for transit route from the transit route to the customer. But so the customer should be protected. But TWNIC is the one of the downstream provider. So we the test results should be not protected between the customers. So we need the other observing point, like the other countries and tests from the transit route and the customer's website. Then we can get the actual result. So it's not a good answer, but we will try to do the next phase.
Okay, thank you. Is there any question about RPKI, about TaiG?
Hello, TaiG, how are you? I'm Jing Hen. I know that you have the project from the ROV test website. I hope to know, is there any IP restriction for this project? Is for just the Japan's IP, or Taiwan's also can use Taiwan's IP to test in your ROV project? Thank you.
Oh, thank you. For the website ROV check, you can use the ROV check website. So let me show the QR code for you. In Koka project, it sends the packet from the testbed to the target network. Of course, we can do the tests for you. So please contact me and let's check any target network. It's even in Japan or even in Taiwan and other countries also.
Okay, thank you. Let's finish this topic. Thank you.
Thank you. Goodbye.
Mr. Taichi Kimura, please remain online for just a little bit while. Now we want to invite our speakers and the moderator to have a hybrid group photo. All right. 接下来我们请主持人还有这个场次的讲者呢一起来到台前，我们要跟线上的讲者也一起来合影一张。在舞台上面的地方，然后摄影师，我们先在这个就是在舞台的，就是您的右手边，好，就是在这个地方是。And Kimura-san, please simply just look into your camera and smile. That would be wonderful. All right, so on my count. Okay, 3, 2, 1, a big smile. And thumbs up. Kimura-san, you know the drill. Thank you very much, and thank you to Kimura-san. Thank you.